I am from AIM Photonics. We are focused on integrated photonics and semiconductor based. It's kind of phenomenal that a startup would be capitalized the way we're capitalized. $15 million in building renovation, $43 million in tools, $25 million to be spent the next round in tools. So we will have about $68 million worth of tools installed in this facility. How can you engage with us? We do development work, we do prototyping work, production work, and service work. And if you have an interest in photonic integrated chips and photonic integrated semiconductor type of devices, we can work with you early on in your project. If you're further along and you need prototypes, we can work with you building prototypes for you. And if you're past the prototype stage and you want to do low volume and medium volume or export controlled assembly and packaging work, we can work with you in that space as well.
My name is Dave Messenger. I'm the director of the Chester F. Carlson Center for Imaging Science over at RIT. We get questions all the time of what is imaging science. And so I have just a couple of examples of what we talk to people about, students and other people, about what is imaging science. It's amazing to me. I go into classrooms or I go into undergraduate programs and I say, does anybody know how your cell phone camera actually takes a picture? How did they take a DSLR camera that used to be like this big and get it into something that's 1/4 of an inch thick? That's the type of thing that our students learn. And it's not just how to actually build the camera system and understand the detector and the optics and all that sort of stuff, but what does your cell phone actually do to that picture when you take it so that you can actually compress it or filter it or something like that? What does the HDR button on your camera actually mean? With satellite-based imagery, all those images that people probably used on Google Maps, that image that you saw on Google Earth was in 3 colors, but the camera system actually has 16 different spectral bands on it. How do we use that data to inform environmental science or harmful algae bloom monitoring, things like that? Those are the types of applications and system level analyses that our students actually learn over the course of our program.
I'm Alexis Vogt. I'm an associate professor and chair of the optics and photonics department at Monroe Community College. We train optical systems technicians, and who is that? That's going to be someone who will work with scientists and engineers in research, design, development, manufacturing, quality control. These are the people who are working with their hands. They have really highly skilled hand-eye coordination, and they build things. So they can be part of your startup as the people who are actually making the product and putting things together. Just since the beginning of this year, 52 different optics companies from around the world have contacted me asking to hire our students. The need is great. MCC is the only community college in the entire country that has a program in precision optics and photonics. So we're teaching students how to handle optics, how to clean optics, and how you manufacture them and take a chunk of glass and turn it to a very precise lens.
I'm Michelle Van de Waal. I'm a Director of Industrial Partnerships for the Cornell Center for Materials Research. So you see on the picture, beautiful Ithaca campus. I invite you all to come hike, taste wines in our wineries and visit our labs. And our role is to conduct cutting-edge research. And we are currently funding 3 interdisciplinary groups, one working on molecular membranes, the other one working on electron spin, and the third one working on photonic materials. We don't only work with Cornell faculty, we collaborate also with Ithaca College, with our colleagues in Rochester, in Syracuse, etc. So if we don't find the right partner at Cornell, we will make sure you can find some help elsewhere.
My name is Scott Carney. I'm from the Institute of Optics. The thing that is really striking about Rochester and the Rochester community is the Rochester community. And within that community, specifically the optics community, it's really an amazingly close-knit group. For all of you who will wind up locating here, I'd like to welcome you. You've hit the jackpot. I have roughly 20 faculty. Those 20 faculty are spread out among disciplines ranging from lens design to quantum optics. We have a fairly robust set of facilities available, including facilities down at Cornell where our faculty go and work, including the TAP facility, including the Albany AIM facility, including collaborations with Alexis and MCC, including collaborations at RIT. Currently just put in a rather large proposal on silicon photonics and quantum optics. And so I encourage you to think of this group up here as a single unit. We are sort of the academic leadership in the community, and we want to engage with you.